Hey Kennedy, this is Miss Tracy. So I was looking at your work, and I am actually looking at the page right now. And what I'm not sure where you got M and P from, because we don't use M and P, we use R and U. That M and P is kind of throwing me off a little bit. So it's negative R and positive U because it's on the negative side of the x-axis. So negative R, and it's on the positive side of the y-axis, so positive U. And when we find that angle relative to the x-axis, it is at the 50-degree angle to the x-axis. So whether you use the 50 degree here or you use negative 230, you're still going to get the same number. And let me show you how that works. Let me get my calculator up. So we use cosine for the adjacent angle because it is CA adjacent. So that would be the negative R. And then the opposite sine would be for the U because that's the opposite there. So if we do 50 cosine times 5, we get 3.21. We round to 2 decimal places unless other directions are given. So 3.21, that becomes your negative R value, which is negative 3.21 R, because we transfer the negative to the value of the number every time. Now for the U, well, before I move on to that, if you were here to use 5 times the cosine of negative 230 degrees, you'd still get the same number. So I'm not sure what you're doing wrong there, whether it is just the way you're putting the buttons in, like 230 negative cosine times 5, it gives you negative 3.21. It's the same value that you get if you use the 50 versus if you use the negative 230 because it's the same angle, right? You understand? So I'm not sure what's happening or where the disconnect is. If you put it in correctly for both, you're going to get the same result. So maybe check how you're rounding the numbers. Maybe that's what's going on. Also, you would get the same values here. So if you did 50 sine times 5, you get 3.83. If you do 230 negative sine times 5, you get 3.83. It's the same value either way you do it. So I'm not sure what's going on. Same thing for down here. We did it exactly the same way, round it to 2 decimal places. All right, so cosine 70 cosine times 3, that's 1.02. The 6 rounds that to a 3. If you're going to round, you have to round up here. You can't just lop it off. It has to be 1.0 rounded up, 1.03. Sorry, I had a phone call and got sidetracked, and now my old brain can't remember where we were. Oh yeah, okay. So yeah, you've got to round appropriately. You can't just chop off the number. If there's a number here that can round you up, you got to round it up. 5 or more, you got to round it up. Okay, that may be where you were having a problem. And then for the other one here, I mean, even if you did the negative 250 negative, right? And then you did cosine times 3, it still would have negative 1.026. You want to round that up. So it'd be negative 1.03. All right, and then the same thing for this one, 70 sine times 3, 2.819, that's rounded up, 2.82. I think you got that one right, if I remember. But yeah, you've got to round everything the same way. You can't round one coordinate one way and one coordinate the other way. You have to have a static way that you do everything. So you can't just chop it off on one and then round it up on the other. You got to be consistent. All right. So work on that consistency and you should be fine. But yeah, always round it to 2 decimal places unless otherwise given instruction for another method. And that's at the end of the problem, not during the problem. Okay. All right. That's all I've got. That's all I saw where you might have messed up. I'm not sure. I don't think you had big mistakes. You just had little things. And like the M and the P on your paper, I have no idea where you got that from. Because we use R and U always. Negative R, positive R, negative U, positive U. So I don't know if you were just doing that to help you see it better or to keep the 2 different problems straight. I'm not sure. But look at that. So you don't want to confuse yourself. You want to always use the same letter so then it doesn't get, twisted around. If you're using the same letter consistently, then you're going to put in the same letter, right? You're not going to get confused by having to convert something. All right, one variable for another. Just, based on experience, it helps to keep it consistent. Consistency in mathematics is important because it follows a stream of logic that is consistent. So if you are consistent, you keep your math consistent, your mode of operations consistent, the way you round things consistent, then you're much more likely to get the right answers and have a trackable method of, oh, well, here's why I went wrong, because I do it the same way every time. I know what I did and what I didn't do. Does it make sense? All right. Anyway, if you have any more questions, please let me know. I hope this helps you to see what you need to do. It's not a hard problem. It's something you have to wrap your head around. So good luck. See you later. See you on Thursday. Bye for now.